if I asked you to define what you thought was the speed, the velocity of an object, what would be your natural thing to say? What would you say as your first answer to how would you define the speed of an object? Think back to the many years of experience you've had. What's the kind of first way we define the speed? Go on, Jack. Distance divided by time. This is how you learn it in GCSE and in secondary school, high school, whatever. Okay, but this isn't quite true, is it? We need to adapt this. This isn't quite true. This isn't quite right. How can we adapt this to make it even more better? Not 100% correct, but still even better. Jack again. Yeah, it's actually the change in distance divided by the change in time. Okay, so it's actually more properly defined as the change in distance divided by the change in time. Now that's fine if it's constant acceleration. Because if it's constant acceleration, our velocity time graph is going to look like that. Yeah, okay. No, ignore that. Apologies. Sorry? Sorry for the viewers. Ignore that. Now that's fine, but how can we now change this even further so it's even more correct? What do we know of change? What is delta S over delta T? What can we write that? Is it even more better mathematically? Charlie? ds dt. Okay. What we've got here, and this is what Newton did. This was Newton's big breakthrough, really, when he invented calculus or discovered calculus. Was that he said that velocity is ds dt, where s is the distance. Okay? This is fundamental. Velocity is the rate of change of distance with respect to time, ds dt. This is where calculus comes into mechanics. It's good for us to join us. Now, what about acceleration? How would we define acceleration? How would you define acceleration very basically? Stephen? Sorry? Go on, force over mass. Yeah, that's one way we could write it. Force over mass. The trouble is mass for an object doesn't tend to change. There are examples, rocket science, the mass will change because the fuel will be taking it, the fuel of the rocket will be going out as the rocket goes. But this isn't, acceleration does equal F over, force over mass. But how do we define it in terms of velocity and time? Charlie?
Change in velocity, change in time.
Yeah, change in velocity. And a change in time. And how could we change that so it's using, even better terminology, Marie? dv dt. Hang on. Velocity is ds dt. Acceleration is dv dt. We could write that in a different expression using the distance. What is the acceleration in terms of the distance and time? We differentiate distance to get velocity. We differentiate velocity to get acceleration. Any ideas? d2s dt squared is the second derivative of the distance travelled. And for this chapter, this is pretty much all you need to know. These three things here. The velocity is ds dt, the acceleration is dv dt, and it's also equivalent to the second derivative of s, d2s dt squared. Okay? So, let's imagine a particle moves along a line, because at the minute we're just going to worry about one dimension. very simple to move it to 2 dimensions. We just introduce vectors, but that'll be another lesson. The particle moves along a straight line according to S is equal to 2t cubed minus 6t. Now, first of all, how would we calculate the distance they travelled between this particle travelled between t is 2 and t is 4? What is the distance travelled between there? How could we calculate that? Sub what sign? Yeah, sub both these values in and do what? The other, yeah, exactly. So we know that the distance travelled at time is equal to 2. It's 2 lots of 2 cubed minus 6 lots of 2, which is 16 minus 12, which 16 minus 12, which is 4. So in 2 seconds, for the first 2 seconds, it travelled 4 meters, and in 4 seconds, 4 cubed minus 6 lots of 4. So what's that? 4 cubed is 64. 64 times 2 is 128. 128 take away 24 is 104. Okay? So therefore, between t is equal to 2 and t is equal to 4, the distance travelled was 104 minus 4, which is equal to 100 meters. Sorry?
18 minus 12 is 6.
Yeah. Proves that even maths teachers can get a bit of. Yeah, so 6. Oh, it's gone like that now. That'll be 6.
How's it 18?
Sorry?
16 minus 12,
It is 4.
Sit down, mate.
So sometimes the maths teacher should be trusted.
You still got the answer as 8 anyway.
What's going on here? Is this the wrong answer here?
You were at 104 minus 6 and you got 8 as your answer.
No, I don't think I did. I think I got it right, didn't I?
Yeah, but you just wrote 8 as your
Right.
answer before that.
Anyone who wants to be a teacher watching this, when you get a student like Charlie over here,
Send him out.
send him out straight away when he questions your dubious arithmetic, even though my arithmetic was correct. Okay. Now, that's fine. There's the distance. What would be the expression for the velocity, therefore? We know distance is equal to 2t cubed minus 6t. What is the expression for the distance? Jack, you've been brilliant. You've been absolutely ace. Someone else. This is Sorrel. Yeah? So what is it? 60 squared. Yeah, 6. 60 squared minus 6. So what is the velocity? How would we calculate the velocity at the moment at t is equal to 4? What would we do here? Stephen? Sub it in. Yeah. V is 6 lots of 4 squared minus 6. Now you know who I'm going to ask to calculate this, just so we make sure there's no mistakes.
How's it going to be 17 for all even numbers?
I didn't say 17.
No, I did.
Yeah, good. 16 times 6.
96 minus 6. Yeah, that's
9 meters per second. That is next level speed. That's next level speed. No. 90 meters per second. Whatever. What about the acceleration? Expression for the acceleration. Jamie. And here we have our constant latecomer. What happened there?
I don't know.
Yeah, I think your headphones are just broken there. Crikey, we're all rocking up now. Acceleration. Jamie, if the velocity is 6t squared minus 6, the acceleration is dv dt 12t. The acceleration is 12t. Okay? Nice and straightforward. This is just essentially call to differentiation. Because they're not going to give you a function, they're not going to give you, in the exam, they could do, but they're not going to give you distance is equal to cos t. You know, we could work that out because we know that velocity is, if we differentiate cos t, we get minus sine t, and the acceleration is equal to minus cos t. If we differentiate again, we could, you know, that the theory still works, but in the exam, they're only going to give you polynomial functions of t. Okay? So that's really quite nice. That's really quite nice. Now, the thing is, we can also go the other way. Let's imagine now that the acceleration of a particle is given by acceleration is equal to 6 minus t. And I'm also going to give you some extra information here. Initially, it is at the origin and travelling with velocity minus 2 meters per second. Okay. Now, first of all, if it's travelling at minus 2 meters per second, what does that tell you about the direction of motion at the bit? Where is it moving to start with? Okay. Well, we've got to define an origin. It's travelling in the negative direction. If our origin is here, and we make up that our plus direction, that our minus direction, it would be travelling in the negative direction to start with, because it's with a velocity of minus 2 meters per second. Now, all we need to know is that ds dt is the velocity, and dv dt is equal to the acceleration. Okay. Now we've got given the acceleration, which is 6 minus t. How can we calculate the velocity? What method do we do to go backwards? Any ideas? Torrent? Integrate. Yeah. So if we integrate 6, what do we get? 6t minus. We integrate t. What do we get, Leo? Minus half t squared. Am I finished? Plus c, constant of integration. So how do we find that constant of integration? Any ideas? I'll put some extra information on that. Slapping t is 0. I call it whacking t is 0. Yeah? When t is 0, what is the velocity? Minus 2. Okay? So slapping these in, we get minus 2 is equal to 6 lots of 0 minus half lots of 0 squared plus c. So it ain't rocket science to figure out that c is minus 2. Therefore, velocity is equal to 6t minus half t squared minus 2. What question do you reckon I'm going to ask now? John.
When t is another number.
Yeah, I mean, we could work out the velocity now at a certain time by subbing it in. Find the distance. Okay. How do we do the distance? Integrate again. This is kind of like there's a process here. One way, go from distance to velocity. Like we could write this. To go from distance, change it like this. That off. No, right. From distant, yeah. From distance to velocity, we differentiate. From velocity to acceleration, we differentiate. But going back the other way, we integrate. Go back the other way, we integrate. Okay, nice little diagram there. So 6t, if we integrate that, we get 6t squared over 2, which is 3t squared. Integrate half t squared, we get, well, it's a t cubed. So we have to divide by the new power, so we get a 6t cubed minus 2t, but we also get another constant of integration, c. What is c going to be? How do we work out c in this case, Stephen?
You know it's at the origin when t equals 0.
Yeah. And
C ends up 0.
well, t is 0 and s is 0 because you know it's at the origin. At t initially, it hasn't travelled anywhere. So t is 0, and we get 0 is equal to 3 lots of 0 squared minus a sixth lot of 0 cubed minus 2 lots of 0 plus c. Again, ain't rocket to see that c is 0. So it's quite nice to know that distance is just 3t squared minus a 6t cubed minus 2t. What about the distance travelled between t is 1 and t is 2? How did we calculate that? Sorry?
We sub t is 1 in and t is 2 and take away.
Take away, just like we did before you turned up. So when t is 1, 1 squared minus a sixth of 1 minus 2 lots of 1. Right, so the distance there, 3 minus a sixth minus 2. So 3 minus 2 is 1. 1 minus a sixth is 5/6. And when t is 2, s is 3 lots of 2 squared minus a sixth lot of 2 minus 2 lots of 2. Well, that should be cubed. That should have been cubed, but 1 cubed. It's 1. So I'm just going to do this. 3 lots of 2 squared is 4 times 3 is 12. 2 cubed is 8. 8/6 is 1 and third. Yeah. Minus 4. So 12 take away 4 is 8. 8 take away 1 and a third is 6 and 2/3. Or because I've got 6 there, I'll write this as 6 and 4/6. So the total distance travelled is going to be 6 and 4/6. Subtract 5/6. The total distance travelled between t is 1 and t is 2 is going to be 5 and 5/6 meters. Alternatively, you could have used a calculator to do all that, but use that to check your answer if it's right. I keep it nice and chill on this because this is, you know, I do my workings out slowly because I know that in the exam this is going to be where I'm going to get a lot of marks, because I know this is just essentially core 1 and core 2 differentiation and integration. This shouldn't pose me any problems at all, because the only functions we get in this polynomial one, so differentiation, bring the power down, take 1 off the power. Integration, add the power, divide by new power. There's no chain rule, there's no integration by substitution, there's no integration by parts involved here. So this is really quite nice. Those of you doing further maths in the differential equations module will know that in actual fact this is very, you know, when it becomes quite difficult when the distance isn't just a polynomial equation. But that's for those people to worry about, not you. Any questions with this?